I call this section more fun with graphing quadratic functions. The goals, number 1, to find the intercepts of a quadratic function, the x and y intercepts. Goal number 2, we want to graph functions of the form f of x equals ax squared plus bx plus c. A, b, and c are constants for any particular problem. Now, this is the multiplied out form of a quadratic function. You don't know what the vertex is just by looking at it. So I'll show you how to handle graphing functions of that form. Goal number 3, we want to find the vertex of a quadratic function by completing the square. And goal number 4, we want to find the vertex of a quadratic function using the vertex formula. Okay, so let's get started. We want to graph f of x equals 2 times the quantity x minus 3 squared minus 1. So what if you were told to get a little better picture, find the x and y intercepts? So you find the x and y intercepts in exactly the same way you do for a line. For any function, you find the x and y intercepts the same way. Let's start with the y-intercept because it's always easier. Y equals, y-intercept rather. So to get the y-intercept, you always set x equal to 0, or the input value, if it's not called x, equal to 0. Okay, what happens if we set x equal to 0 here? In other words, what happens if we find f of 0? We get 2, okay, we put a 0 right there. 2 times negative 3 squared minus 1, what is that? Well, I don't know, what's 3 squared? Negative 3 squared. 9 times 2, 18 minus 1, 17. So 0 comma 17 is the y-intercept. Notice I didn't try graphing that. It would be way the heck up here somewhere, wouldn't it? So I'm not going to include that in the graph. Oh, that's okay. If it's convenient, include the y-intercept in the graph. If it's not convenient, then don't. So anyway, that is the y-intercept. Did everybody see how to get that? Yeah. I'm plugging into the equation, right? So f of 0, you plug a 0 in right here. 0 minus 3, that's negative 3. Squared is 9, times 2 is 18, minus 1 is 17, right? So that's just, please excuse my dear Aunt Sally, do the exponent first, then multiply, then subtract. So you get 18 minus 1, 17. Everybody good on the y-intercept? How do you find x-intercepts? X-intercept, and there's going to be more than one for a parabola. You can see it, right? You can see that there's 2 of them. It crosses the x-axis in 2 places. So you set y equal to 0, so you could replace f of x is y, right? So replace that with 0. And you have this equation, 2 times x minus 3 squared equal minus 1, and then you have the 0 on the left side. I don't like that, so let's put the 0 on the right side. 2 times x minus 3 quantity squared minus 1 equals 0. I like that better. Does it matter? Not really. But I like having the unknown on the left side. How do you solve an equation like that? You got to solve that for x to get the x-intercepts, right? How do you solve that? Well, you have the quantity x minus 3 being squared, right? So, well, you could, but that would be the hard way. Well, you've already got this guy as a perfect square. X minus 3 is a perfect square. Couldn't you solve by taking roots? No, there's some work to do first. You have to isolate x minus 3 squared. But think about it. If I want to solve for x, I want to get rid of this exponent of 2, right? Since there's no other quantity involving x, the best method is solving by taking roots. Before you can solve by taking roots, you have to isolate the thing being squared. So how do I isolate x minus 3 quantity squared? So I add 1 to both sides. I get 2 times x minus 3 quantity squared equals 1. Divide both sides by 2. I get x minus 3 quantity squared equals 1/2. Okay, is everybody with me so far? Okay, I'm going to go up here to finish this off. What do I do to both sides? Square root. What do I have to remember in front of the square root of the half? plus or minus. So I get x minus 3 on the left equals plus or minus root 1/2. I'm going to break that up. Isn't it root 1 over root 2 plus or minus root 1, which is 1 over root 2? The square root breaks up over division, right? Most answers will have that rationalized. So how do we rationalize 1 over root 2? What do you multiply by numerator and denominator to get rid of the radical in the denominator? Root 2, so let's do that. And then that gives you x minus 3 equals plus or minus what? Well, not 2 but on top, but 1 times root 2 is still root 2, and then on the bottom, I agree, you get 2. And then if you want to get x by itself, what do? Add 3. So you get 3 plus or minus root 2 over, now the way I've written it, that division bar is just underneath that root 2. Okay? So what are the x-intercepts? There's 2 of them. You could write them all in one as 3 plus or minus root 2, just the root 2 over 2, comma 0. It's a little bit abstract, so let's change it to decimals, right? So to get the left-hand one, we're going to use the minus from the plus or minus. So the left-hand one will be given, the x-coordinate will be given by 3 minus root 2. Try it again. Root 2 divided by 2. There we go. So about 2.3 if we round. So approximately 2.3. This is just approximate, comma 0. That would be the left-hand one. How do you get the right-hand one? What's the easiest way? Second function, enter and edit what you just punched in, make it plus. About 3.7. That's approximate. Do you think you can check your answer easy enough on the calculator? We have, I'm going to type in y1 in for f of x, and well, actually it's y1 automatically, and then 2 times x minus 3, gosh darn it, 2 times x minus 3 quantity squared minus 1. Graph that, zoom number 6 for a standard screen, negative 10 to 10. First of all, does it look like the graph we got? Well, it's going up further than I went, but it basically looks like it, right? The scaling's slightly different, but it basically looks like it. How could you verify so that you're absolutely positive this works? Well, you could find the 2 x-intercepts. That would do it. And you can punch in the vertex. You could verify that when you punch in, hit trace, punch in 3 for x, and the cursor should go to the low point in the graph, and you can see it does. So you know you got the right vertex. And then you could punch in, let's just do one of these. Let's do the left-hand one, the left-hand x-intercept. Oh, by the way, if you wanted to, you could punch in 0 for y, or for x rather, and get 17. That was the y-intercept, 0, comma 17. You could verify that. And then you can also verify the x-intercepts you just found. Let's do 3 minus root 2 over 2. You got to hit trace first for this to work. So 3 minus square root, make sure you can see that. 3 minus square root 2, close the parenthesis, divided by 2. What should pop out? If that's the x-coordinate of the x-intercept, what should pop out? 0. It does. And 0 will pop out if you type in the right-hand one. With technology, you can know for sure that everything you did is correct. Okay?